on. So we're going to talk a little bit about JavaScript, the overall characteristics. We'll talk about runtime environments, what those are, importing and exporting modules, and also how to manage packages and versions. And so at a high level, JavaScript is a high-level programming language. It's interpreted, dynamically typed, in multi-paradigm. And so to get just an idea of like what a basic JavaScript program is we can look at here. JavaScript reads pretty straightforward. We're defining a function, which is starts with a function keyword. We define a custom name for our function. Our function can take one or more parameters. And here I'm defining a function that takes a list of numbers. And we won't worry about this keyword here, reduce, but you can kind of get the idea that it's going to take that list and it's going to add all the different values to output a sum. And here I'm dividing the sum by the number of grades to calculate an average. And you can see here I'm actually now defining the list of numbers that are our grades and invoking that function to output a final value. And then here I'm using the console, which is a way for us to output the result of our program. And I'm formatting this to be a percentage. And so that's a very basic JavaScript program, but highlights a lot of the different types of functionality you would get from JavaScript. And so when we talk about it being high level, we're really talking about not having to dig into the lower level components of writing programs. And so basically, to keep this part short, when you're dealing with the lower level languages, they tend to require a lot more knowledge about the actual machine in question that you're building it on, the actual hardware of your computer, and the architecture, where a high-level programming language like JavaScript or Python or Ruby, they tend to not be as focused, or they don't need to be actually specifying specific parts that are aware of the machine. And so because of that, you can have very expressive programs. This one is a prime example of defining some data structure, in this case, a list of objects. And you can see each object has a key for name and direction. And then we can simply iterate over that list with a very expressive for each. So this reads really clearly, passengers for each passenger. And then I'm using a very basic conditional that is easy to read. If the passenger's direction, and this triple equal sign means equals departing, then I console log out some value. And here I'm actually embedding a string again into a value into a string and calling the passenger name key. And so this is really expressive in a short amount of code. And we didn't have to think about anything about where the data is being stored on the machine or anything really specific. It's kind of almost natural language in the way that it's written. And so JavaScript is also dynamically typed. And that means basically we've already looked at a bunch of different data types like lists and numbers and strings, and we didn't have to explicitly define what that type is. And so other languages do require you to say, when you're defining a variable or a function, what is the type of the argument or the variable value ahead of time. And this is used during compilation. So for compiled languages or statically typed languages is the term when you have to explicitly define data types. They use those checks to look for problems in your code. And so in some senses, dynamically typed languages can be abused a little bit more. And so, but they are easier to work with because you don't have to do the additional thinking of typing your programs. So if we look at our previous program, just to kind of point out what the data types are, we have grades, which is an array. The sum is going to be an integer. When we divide the value, it's going to be a float, potentially a decimal. And same thing, this is an array. This final value is going to be a float. And then in the case of this message here, this is going to be a string. And so we can run into issues when we're trying to use a data type that doesn't support something. So a simple example is I define some number variable and I try to call to uppercase, which isn't a function on a number. That's only a function on a string. And so you have to think about the types that you're using as you're writing your code. And so what makes JavaScript interpreted? What that means is that an interpreter will take your JavaScript code and immediately execute it. It might put it in some intermediate format, but then it will just do the process of executing it, where interpreted language can be contrasted with a compiled language that will actually take the code and put it into a lower level machine language that you then will execute. And in practice, many of the high level languages like JavaScript, Python, Ruby, those are all interpreted programming languages. But there are pros and cons of both interpreted and compiled languages that we won't dig into here today. And then just kind of quickly going through some of the other paradigms that JavaScript enables. Here, for example, we're using JavaScript object-oriented programming. So we're defining a class that has a constructor and you can add different properties to this object, as well as add different methods, which is really a function on the particular class. And then here we're creating an instance of that class and creating new dog, and I can call the attributes we've defined, as well as the methods that we've defined on it. So this is a way that we can model certain types of programming problems. JavaScript can be used for imperative programming. So here, I had previously used that method reduce to calculate a sum, but here I'm calculating the sum manually, actually taking the array and having a result being calculated. So we don't have to dig into the specifics here, but this is kind of an imperative style of programming. And then here, I mentioned before, we have a function called calculate sum. Similar here, I'm using the reduce function, and this is an example of a functional programming. And you can see the difference in kind of size. Functional programming can sometimes have a slightly smaller footprint when you're refactoring. So we're gonna
Joe,
go ahead. Mm-hmm.
We do have a few questions here.
Sure. Mm-hmm.
So the first one is from Mary, and the question is, are there efficiency or speed differences between dynamic and statically typed languages?
Yes. So it depends on the language. It's hard to compare when you talk about compiled versus interpreted. In general, compiled languages are considered faster for a couple reasons. They're able to do certain optimizations ahead of time. So when you're talking about like execution, the lower level that you have, and like compile tends to be faster, but there's exceptions to that rule. Languages that do interpreted languages that do some type of compilation, they call it just-in-time compilation, can be equally performant. When it comes to writing statically typed versus dynamically typed programs, in general, it tends to be a little faster to do dynamically typed because you just don't have to think about the types. But the statically typed programs might catch more bugs ahead of time because it won't let you compile the program until all of your types are defined. So there's pros and cons from a development speed. Any other questions there, Reshma?
Yes, there is another question, which is, earlier your slide showed that JavaScript, Python, Ruby is languages. In terms of choices, JavaScript is the most popular. Other than stylistic differences, is the performance of both languages the same, and is there one that's better than the other?
Yeah, this is a really common question that folks ask about performance. In general, like nowadays, most applications, if you're going to go build a backend with JavaScript or Django, with the kind of computing power that we have, like performance of languages tends to be less of the thing that you're thinking about. There are like performance intensive applications where you might want to choose something that's more performant. But when it comes to like getting into programming and like choosing one language or the other, it tends to be more like what can you do with the language. So for example, JavaScript's really the dominant and almost the only language that you can really write web applications. So if you want to do front-end web development, then you should go learn JavaScript. Similarly, for Python, there's things that Python can do that a lot of other languages can't do or are not as versatile, like data science and machine learning, where you can't. There's not as much support in JavaScript for machine learning right now, although the community is growing and trying to do more like that. So it's more like what's the use case and kind of what's the ecosystem that you have. But you can't, if you're trying to get down nitty gritty, in general, JavaScript, Python, and Ruby, like all of those languages are not as fast as something like a Java or a C++. So there are pros and cons when you're choosing a language, both from a performance as well as like functionality standpoint.
And one more question, is the $ open curly bracket content, close curly bracket, only used for inputting values into a string?
Yes, that syntax, great question, is a relatively new syntax for embedding data directly into strings. But it always has to be in a string. That's like a backtick, as you can see there. And actually, I think I have an extra paren there. That's a typo. But in general, yeah, we can see you will only be using that curly $ curly brackets for strings. Okay, I think any last questions before we move on?
No more questions.
Okay, excellent. So we've already touched upon this, but when we're talking about JavaScript and we're talking about runtime, that's basically when is the interpreter running your program? Where is it? Where's the interpreter? And so the primary places that the runtime of a JavaScript program is either a browser or the Node.js runtime environment. And so browsers you're pretty familiar with already. You use them every single day, and that's kind of hidden from you. But Chrome and Firefox or Edge, any of those browsers, they have an interpreter and a runtime environment for JavaScript. And then Node.js has come along in the last couple of years, and now it allows you to write JavaScript like you do on the back end for like other application languages like Java or Python, Golang. All those languages require you to be able to run in like a virtual machine environment. And so Node.js allows you to do that. And so we already talked about browser runtime environments, but in general, those runtime environments need to be able to also interpret CSS and JavaScript together that work together to make your web application. And then the Node.js environment, like I said, it can be used for writing command-line tools, server-side applications, and produce dynamic web content. So it really, JavaScript through Node.js is one of the only application languages that you could build an entirely full-stack web application just in one language, where if you tried to do that in Python or Ruby, you would have to use some pretty bespoke tools to achieve everything that you would want to achieve with Node.js. So even if you're building an application with Django or Ruby, you're going to still need JavaScript, where JavaScript can build a full application without any of the other languages. And so we're going to quickly talk about importing modules, and this is going to be really important when we start using libraries. So here's an example of in a Node.js environment, I'm loading the file system module. I'm also importing a specific function from the path module that deals with file paths. And then here I'm using a Node.js function to actually read a file and get some data. And so this is a basic example of importing something that comes directly from the standard library. And then here I'm defining some custom modules. So here I have a file called num-utils, and I defined a couple example functions. And then here I'm importing those functions. So it's similar, import the name, a default function or default value, as well as named functions, followed by a from, and then the file path. And here I'm just using one of the functions. And so in addition to the standard library and custom modules you've written, there's also a huge ecosystem of other packages that that you can use to build applications, including React. And so, like, how do I get React or get any other type of application library into my application to work? And so this is where Node Package Manager, simply NPM, which is both the name of the command and also the registry is called the NPM registry, which is an online registry of all of these different JavaScript dependencies. If you're familiar with Python and the Python registry and pip, the install tool, it's very similar in the way that it works. It gives you a quick way to define a dependency and install it. And so we'll look at how to use that. It looks like this when you're at the command line.
Joe, just a quick thing. At the bottom of your screen, it says big marker sharing your screen, hide. If you could just hide that, that'd be great.
Yep. Thank you. And so here's a basic example of using NPM. And we'll have to remember, too, that NPM depends on you having Node installed. So you already have Node installed. I didn't go through that process, but there's a bunch of different ways to get Node. But once you have Node installed on your computer, you would call npm install. And here's an example of me installing a library for generating unique IDs. And then once I have that installed, as long as I'm in the right the right folder, I should be able to just simply do something like this: import the newly installed dependency, and then call it. Here it's generating the unique ID. Similarly, when you have Node, just like any other language, sometimes you need to be able to switch between versions. And so there's another tool called NVM, Node Version Manager, that allows you to switch your different versions. So here I'm giving an example of NVM install Node 18.4. And so it's a really easy way for you to get up and running with Node and be able to switch Node versions. And so, like I mentioned, we have the Node Version Manager. And so before I move on, is there any questions about the kind of foundational stuff that we just talked about there?
I see no questions.
Great. Alrighty. So we can then kind of quickly move into web development libraries and frameworks. So we've talked about the foundations of web development and also that basically all frameworks and libraries that are related to web development ultimately will spit out some type of HTML, CSS, and JavaScript, as well as additional data interchange formats. And so we already kind of touched upon this, but there is a distinction for React where the community calls React a library. You could potentially say that it's a framework for building user interfaces, but you'll see that React is kind of used interchangeably for as a framework, along with some other front-end development frameworks. So that might be a little bit confusing. Quickly, why are web development frameworks needed? We looked at that very simple example of using HTML, CSS, and JavaScript in a single file, but you can imagine that gets really complicated, as well as all the other stuff that you have to do. And so this is not even an exhaustive list of all the concepts that are related to web development. But we're not going to have to really worry about them too much. We're going to be mainly focused on just the client web development frameworks. And so, again, these are JavaScript-based frameworks. There are also CSS frameworks that you will hear about. Those add easy ways for you to style your application that are not necessarily like dynamic behaviors that are added to your components. And so there's a distinction when we talk about JavaScript front-end frameworks or CSS frameworks. There's that distinction. And then when we're talking about popular client-side libraries and frameworks, we have React, Angular, Vue, Ember, jQuery, Next, Nuxt, Gatsby. There's too many to name. So choosing one is difficult sometimes when we're trying to find the right solution. And then here's some CSS frameworks that are also popular right now. Quickly, just to touch about server-side frameworks, because even if you're building a React application, most likely there's going to be some back-end application that you're talking to. These tend to be written in a variety of languages. Like I said, it can be Node.js, could be Python or Ruby. And increasingly, back-end applications are mainly just sending data to the front end for an application like React to consume. That's either JSON or XML. But traditionally, server-side frameworks would do everything, including serving up the actual HTML and CSS and embedding data from the database into that data. And so that's in the realm of like Django or Ruby, as well as Express, Laravel. These are all kind of full stack server-side frameworks is another way that they might be framed. And you might hear this term single page application. Really what a single page application means is that you're serving a single HTML file that has one or a couple imports of JavaScript, and that all of the other behavior is basically implemented in JavaScript, including loading data. And so you don't have multiple trips to the server. If I make one request for one page, the server-side framework would make a whole page refresh. Where a single page application, you won't have any page refreshes because the server's not sending a new page for you to redirect to. It's all one file. And we'll actually see that pretty simply when we actually dig into React. And so I ran through a bunch of frameworks. Is there any questions about frameworks or framework choice, libraries there?
No questions so far?
All right, so we can keep on moving along here. So we're going to finally get to React. I know it's been a little while, but you can't really get React until you understand the foundations that we just talked here. But hopefully with that foundation, we'll be able to quickly kind of build upon what you know and start doing something exciting with JavaScript and React. And so coming back to the example we have here before, this would be your standard HTML. And in React, it would look something like this. This is not complete. We'll talk a little bit about this, but the core functionality was that we had a header and a button that had some functionality. Here's an example of that same code. So when we looked at JavaScript before, we saw we could define a function with the function keyword and then a function name. Here, the function name is going to be hello world. And the return value we're looking at is actually called JSX. And it means that you can embed a variant of HTML. It's not exactly HTML, but it looks very similar to HTML right in your JavaScript. So that means that I have a function called hello world, and the return value is actually going to be this markup, this HTML or JSX really. And then I can also add additional values. Here I'm styling the h1 tag directly in this case. And then here I'm setting an on-click event. So when the button is clicked, and I'm doing the same thing I wanted to do in the previous example of triggering an alert. So that's kind of how, when we talk about React components, you'll hear components. This is the most basic example of a tiny component that does some functionality. And then here, this is actually how we get it into the application. And so when we talked about the document object model, I'm using the standard vanilla JavaScript is what we call it when you're just using regular JavaScript. And I'm getting an element in a HTML file. In this case, it's probably a div called root. And then I create this root using a tool called React DOM, which works in conjunction with React. And then it says render. And so what that will do is render my component. And you can see here, it looks like I'm using an HTML tag starting with an open and closing tag. But this is my custom hello world component. And that will actually spit out some HTML. And so this is actually how you get an application. So when we were saying before, if you had a single page application, you would have an HTML file with a single element with an ID of root. And then I'm actually rendering all of my JavaScript code and the HTML generated through that render function. And so React components can also have properties. So here I'm defining a custom function. This syntax looks slightly different. This is a kind of abbreviated, they call arrow function. That's a little simpler than a function, and it's easier to fit into a slide. So I used it here. And so here I'm also defining a function, and the return value is going to be a div with a class name. And it takes a text property, in this case, just a string, and it embeds it in my h1. And then if I use my new component, my page component, I can pass down the property. And then what we'll get is, this is what actually is output, right? We get a div with a class. You can notice that in JSX class name, this is an important distinction. The HTML is just class, but in JSX it's class name. But ultimately, this is what's generated from the final, from rendering our component. We can also layer components or compose components into each other. So here I have a page layout component, and there is a keyword called children, which basically means any of the components that I pass down to it. And so this is maybe I want to just have a div that has this class name that I can use for styling and pass down the children to it. Here I can use that component and pass down this. So I get this same logic before, but now I have this like separate component here. And so this allows us to compose them together, but the output will still be the same output. But now I have this reusable page layout that I can use anywhere. So if I want to use that same page layout on every page, I'm able to import it and use that component. And so this is how we start getting reuse, is one of the big benefits of using React. And here's an example of doing something a little bit more interactive or dynamic. Is we're going to be rendering a list of users. And so here I'm passing a property to this users list that's going to be an array. And I'm using a little bit of JavaScript functional programming using the map function. And what this means is go through each user in this list and return whatever this return value is. And here what I'm returning is a component I've defined. And so you can see this is an unordered list in HTML. I'm rendering a list of list elements, and this is the output of that, where I'm actually passing down the user name into the list element. And then here I'm putting it all together into a page. I'm using my page layout component from the previous section. And then I'm rendering this list, and then the output will look like this, a very basic HTML. And it seems like, well, why wouldn't I just write the HTML? This seems like a lot more, right? But you can see how this quickly gets powerful, where this users list is dynamic and it's getting loaded from somewhere. Now we don't have to like manually add list elements. It's going to be the complete output of our components. And so last couple pieces before we hopefully look at some real code is, how do we handle things like input, for example, or updating the state of the page somehow? And so here's a kind of contrived example of like a note form. And we're going to use a keyword function called useState on React. And what useState returns an array where the first value is actually whatever the default value is. And then setNote, which is a function that will set that value. And anytime setNote is set by a user action, the whole component will re-render the state of the function. So we'll look at this later on, but this is a really important functionality, which is that when a user makes a change to the underlying data, we want the whole application to update, and we don't have to do it manually. Where in a normal JavaScript environment, once you made a change to the data, you would have to like go find the particular part in the page that you want to change and explicitly change it. Here, the data change will flow organically down. And so when we make a note first, we call setNote on change, it will actually update that. And then when we call handle submit, you can see here I'm in this example, I'm calling some function to post an update to a note, and then I call setNote again, which will update my component. And then finally, there's and also before I move on, there are a lot of other keywords. We're only touching a handful that we're putting together to build something, but there's tons of other specific React functionality that we're not going to cover today. But we're going to be covering the bare minimum, but should open you up to be able to play more around with it. And so really the last core functionality that we're going to talk about today is called useEffect. And what useEffect does is it allows you to hook into what we call the lifecycle of a component. So when a component renders for the first time, if you want to do something at that point of a render, or if something changes, some piece of data, and you want to trigger some additional functionality that hooks onto that, you can use useEffect. And useEffect takes two functions or two parameters. One is actually a function that will be called when useEffect is triggered, and a second argument, which is an array. And if nothing is called in the array, then it will only run once when the component renders. But if you add additional parameters to that array that you want to change or call when the useEffect is changed, you can pass them in as well. And so in this example, we're doing something really simple by having like a loading state, and we're fetching some data from a server. We're setting a list of notes, and here I have like an example component. And I also have a loading state. So when this component loads for the first time, it will have a loader and it'll say loading. And only when the data has been loaded from the server do we set is loading false, which will then render our list of notes. And so this is a way for us to kind of combine use state and use effect to have a graceful functionality when it comes to loading some data and rendering different components based on those state changes. And so with that, before we go on to kind of doing a very quick example of using this in practice, I want to make sure that I answer any questions because I know we covered a lot there.
Yes, there are quite a few questions.
Mm-hmm.
The first one is from Daniela. Can you elaborate a bit on the benefits of SPA? Why doesn't the page reload? Is it better for SEO, which is search engine optimization, I guess?
Yeah, that's a good question. So the reason it doesn't load is in the case of a server-side application, it tends to be the case or a full stack server-side application that handles rendering the views. When you click a URL and you follow that link, the server will completely send up a whole new page. Even if the page looks exactly like your other previous page you just went to, if you go to a new page, it will generate that whole new page. So you get a page refresh. In the case of a single page application, all of the client-side logic has been written in JavaScript. It doesn't have all the data, but it has all of the structure of the HTML. It has all of the business logic that happens on the front end. And so when you load a single page application, it loads with that data, the structure and the dynamic components. And then JavaScript uses what's called the AJAX, the asynchronous JavaScript in XML, to communicate with your backend server by making a request and loading data, usually JSON, which is one of those interchange formats. And then it dynamically updates the front end using the document object model, or in our case, we're going to use React to update the front end, but it never needs to refresh because the server isn't sending a request that will make you redirect. It will just send you a little bit of data, which means that we don't need to also send HTML every single time we hit our server. We only need to do it the first time the page loads. There was a question about SEO. Traditionally, server-side applications have been known to be better for SEO, but there's tooling to enable even a React site to have pretty good SEO. SEO is a pretty challenging thing to do in general because you're really trying to like reverse engineer other services like search parameters. But there are considerations when you're building a single page application.
The next question is it the case that all React is embedded inside a function call? Can it be inside a class as well? Also, do I really need to do that, or can I just reference a style sheet someone else created?
Okay, so I think there's two questions there. The one is, yes, there are class-based components in React, and I did not cover them in this tutorial. In general, class-based components are still in use, but the community has kind of moved towards using function-based components, using use state and use effect versus using class-based components, which has their own kind of approach to managing state and the lifecycle of components. So you might see in tutorials out there class-based components, and they're perfectly valid. But in general, function-based components tend to be increasingly popular. And then the question about style sheets, there's a bunch of different ways to style React applications. There are frameworks that have pre-built components that you actually import and use. There are CSS frameworks that export classes that give you functionality. And yes, you can define custom style sheets outside of your React components. You don't have to do inline styles like I had in that contrived example. You can have separate style sheets.
The next question is, what is the best way to learn React if we know HTML, CSS, and JavaScript? Where to begin?
Yeah, I think the next section here is going to be a great answer to that, of how to start playing around with React today. When we dig into this last section here, I'll give you a little bit of a primer on how to start playing around with it. Hopefully I'll be able to answer that question. Is there any other questions before we move on to this last section?
Yes, there's 2 or 3 more.
Okay.
The next one is, when do you recommend moving to React? After you create something with JavaScript, or when you have a good understanding of it?
I would say that you should really have a solid foundation of JavaScript before you attack React. I think it depends on where you're at. You could learn React kind of while you're still learning the basics of JavaScript, but you'll see in the example that there are some foundational concepts from JavaScript that you really need to know before you dig into React. As for when you're building a project, every project's different. If you already have a JavaScript project, it might not be worth it to try to move it to React. Sometimes it is. But yeah, from a learning perspective, I would definitely do the foundational work if you don't feel strong on JavaScript first.
What is the simplest way to explain async and wait functionality?
Yeah, I will also touch upon that. But the async wait functionality is a way to work with something called promises, which is a kind of a deeper, complex problem that we don't have a lot of time to discuss. But in general, it's a way for you to do something like a request that has a certain amount of latency, or you have to wait around for it. And so you want to be able to tell your code to wait for that thing to complete before you go to the next step. There are also ways to kind of do that out of order, and if you see the async await, that's a new kind of part of JavaScript that makes it easy for you to model that.
2 more questions. What is the role of asynchronous JavaScript here with the async keyword?
Yes, I'll say we're gonna touch upon that really in the first couple minutes of this next section. So you'll see it be used a little bit more in practice. It will make sense.
And the last question is, how does React handle error amongst the component parentheses functional component?
Yeah, error handling is kind of a bigger kind of problem set. In general, React components themselves tend to be very declarative, and you don't have as much business logic written in them. Usually when you're dealing with errors, it's going to be separated out into a separate component or a separate util that has error handling built into it. But yeah, error handling in general is kind of more of an advanced topic to go into for React. So maybe the next presentation will dig into that more.
And that is it. We're ready to move to the next section.
Okay, great.